So now let's go ahead and write some methods that we can call here. I'm going to create a new method that I want to be publicly callable. I'm going to start with my at app.externalDecorator. I'm going to create a new method and I'm going to call it logger. And what I'm going to do is I'm going to go ahead and pass in two variables. A is going to be an ABI.string and B is going to be an ABI.string. All I'm going to do in this method is I want to log A and then log B, then log A, then log B, then return A plus B. So the concatenation of A and B. So in our logger function, we're going to take in the A, the B, and then go ahead and add our output. And this is also going to be an ABI string. And so now what I can do is start running out my logic. Okay, so if I notice that what we want to do here is we want to return an expression. I notice that we're not actually returning anything here. So how do we actually, so if we were to call this, then nothing would happen on chain. Because again, the only thing that happens on chain is whatever expression that we return. Right now, we're not returning expression. So if I were to go ahead and type return, let's set, what would happen is we would successfully call output.set. However, our other things won't get logged. So let's take a look at what that looks like. So I'm going to go ahead over to our deploy script. I'm not going to go in depth into this code yet, but what I'm going to do is I'm going to come down here, just change this to logger by A as hello, and B world. So what we expect to happen here is when we call logger, what we wanted to do is log A, log B, and then return our values. If we go ahead, build and deploy, I need to, so we go ahead, build and deploy. And now we can see we've logged hello world, which is what we expected, or we've returned hello world. But I want to go see if it actually logged the values that we wanted it to. So to do that, I'm going to go ahead, open up AlgoKit LocalNet Explorer. And AlgoKit LocalNet Explorer will then open up an external website. On Gitpod, it's going to ask to make sure that you want to open it on your local machine. It should just open it right away. So we're going to go ahead and open it. And if we come to our transactions here and we can see our latest transaction, the timestamps are off. This is expected on a development network because the timekeeping mechanism is disabled. But basically, if we go ahead and take a look, we can see we have two transactions, one for creating it and one for calling it. So we can go take a look and we can see in our logs, we've logged our concatenation, but we haven't logged A and B. And the reason we haven't logged A and B is because they're outside of the expression that we return. So now the question is, how do we return multiple expressions? How do we do multiple things in one call? We use this handy dandy class called sequence or seq, which stands for sequence. We're going to go ahead and paste in all the things we want to happen on chain into our sequence. Have a comma there. Okay. So now we can see what we're returning in logger is now a full expression that has log A, log B, and then also return. So I'm going to go ahead, build and deploy. Hello world. Going to head over back to Dappflow and go to the latest transaction. And I can now see, now that we've added everything in the sequence, we logged A, we logged B, and then we've returned our value. And so you might notice that our return value here is actually underneath the logs output. And that's happening because on Algorand, there's no actual native concept of returning a value from a contract. Instead, a return value is simply a value that's logged to the contract with a specific prefix. And this is what that prefix looks like. So when you see the pipe U space, that signifies that this is the return value of the contract. Okay, so we've created our first very simple method that actually logs some stuff. So now let's talk a little bit about building out an actual functional application. So let's build out a calculator. So my first method I'm going to add to my calculator is an add method, add. So now in this method, what we're going to do is we're going to return the value of A plus B. So we're going to return output.set A.get plus B.get. Now what this method is simply going to do, it's going to return the value A plus B. Pretty straightforward. And so now I'm going to show you one other useful thing. So I'm having to go to my build, run and debug every time and do it through the GUI. If you want to execute locally, what we can do is call poetry shell. This will enter us into a shell with our Python environment set up for us. And we can run python.py. Sorry, I'm going to run python .py, and that'll call our deployed script, much if we were to go over here to build and deploy. And I'm just going to be doing that instead, just so we can save a little bit on screen real estate here. Okay, so now let's go over to our deploy app. We're going to go down here to where we're actually calling it. And we're going to call the add method. And we're going to call 4 plus 6. Expect that to be 10. Let's go ahead and run it. And there we go. We see it's 10. Now what we want to do is let's add another method and let's call it subtract. We're going to do the same thing, except as you guessed it, to A get minus B dot get. Return expression here. So let's go ahead. Change this to 14 minus 6. Change this to subtract. I think that's what I called it. Yep. Go ahead and run it. E minus 6 is 8. Okay, so now let's go back to 4 minus 6. So this is going to do 4 minus 6, and we'd expect the value to be negative 2. So if we go ahead and try to run this, it's going to throw us an error and say, this transaction that we just tried to send, it had an error. This subtraction would result negative. And so this is one of the first really important things to remember about Algorand smart contract development is that we're always working with unsigned 64-bit integers. And that's because the AVM itself only knows unsigned 64-bit integers natively. So if we try to subtract a negative value, or if we try to subtract a bigger number from a smaller number, then it's going to throw us this error. And we can see here, it told us where in the program. So this is the program counter and the teal source line 213. So what this 213 maps to is if we go ahead and open up our approval.teal, come down to 213. This is where that's off by 1. So this is where, though, that it's actually running into that error. So we can see here our subtract 4, proto 1, and see blah, 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 blah. That's where we are. So when you get an error when developing your smart contract, it will always tell you the teal rather than the PyTeal because the AVM doesn't know how to interpret the PyTeal directly. So it only shows you the teal itself.